All right, I'll be showing amongst other things, a Pico SDR, Raspberry Pi Pico SDR receiver. Started off as a project by John. Oh, great. Now I'm drawing a blank. Yep. Um, anyway, I'll remember his name at some point. We start, uh, roll back a little bit. I'm a member of the Cal QRP Club. I'm one of the guys who designs kits and builds them, tests them, makes cases. So let's see. Anyway, this is one of our projects we did, a little SDR receiver. This is the breadboard version from the start of the project. Did a few versions of the PCB, getting better and better, one hopes. Ultimately ending up with this guy. Let's see if it's working today. Upside down for you guys. Okay, there we go. So it pretty much tunes from near zero up to maybe about 30 megahertz, AM, CW, USB, LSB, whatever you like. Um, anyway, it's a cute little radio. It's a Raspberry Pi Pico in there, doing all the decoding. Yep, drawing a blank on his name. I had it all written out, but that's life. This is a fun project. If anybody familiar with the CalQRP Club projects, okay. Okay, so yeah, we do one or two projects every month. We make 25 kits. If you get on the list, you can buy one. If you're not on the list, you can buy a PCB and build it yourself. We don't release the Gerbers, I guess, at this point. Did a few other projects. There's a little, this is a SSTV decoder, again, by the same guy, John Dawson. We're looking at making it into a kit. Got a little prototype version here, a lot of breadboarding space just for testing, debugging. And what else? This is a little frequency counter kit we did a way back, 2 months ago. I only did the case on this one. And same for this little frequency reference. What else do we do? One of the latest projects, latest one this month is a LC meter. Is anybody actually getting the kits here? Okay. So one of them is a crystal tester that's going to be coming up as useful for one of the projects we're doing for Pacificon. So CalQRP has a meeting. Instead of doing the banquet on Saturday night, we've got our own QRP meeting. And one of the events is we're going to be selling a new version of the NorCal 40 QRP radio. It'll be updated, but I think you've got to sign up and you've actually got to show up to pick it up and pay for it. No mail order, no, I'll pick it up from you later sort of thing. Well, that's it.
And there was there a website or was somewhere we can go for this again?
No.
Oh, the kit. No, to purchase these, it was a.
Yeah, the CalQRP mailing list on groups.io.
Oh, okay.
Groups.io. So you just hop on there and like everybody will say, hey, can I get one of these? And Doug will say, no, you can't get one of these.
Okay.
But you can buy a board maybe.
Okay, gotcha now.
You. For the past several years, I have taken a trip to Colorado every summer to engage in the Children's Hospital Foundation's Courage Classic bike ride. It's a big ride, about 1,000 people, raises millions of dollars for Children's Hospital in Denver. And Children's Hospital bike ride leaves from Copper Mountain, which is about 2 hours west of Denver. The riders go up in the high country over Fremont Pass and Tennessee Pass up to 11,300 feet, come down Vail Pass. Cell service pretty spotty there. So we support the ride with ham radio. We have a ham station at each of the aid stations on the ride. We have a ham station on each of the sag wagons. So to ride along in a sag wagon, I had a need for a portable radio with voice and 2 meters and 440 and APRS, automatic packet reporting system. I needed to be self-contained, that is independent of vehicle power. The reason for that is there was an unfortunate incident a couple of years ago that wiped out an automobile's computer. So we don't want to do that anymore. So here is what I came up with. Can we go vertical? How do you want to do this? Front view. All right. So I built my Go box in a tackle box, which is almost big enough. I put the control head for my Yaesu radio on the front. I hang the microphone on the side, and then inside, and you may want to go overhead on this. I will see. Thank you. It's, yeah, that I might have chosen a slightly larger package for this had I known. In the box, I've got my 20 amp hour lithium ferrophosphate battery. I got the body of my Yaesu FTM 100. I got my old Radio Shack 2-meter radio, which is my APRS radio. And then I've got this mobile linked TNC terminal node controller. The TNC connects with the audio on my Radio Shack radio, and it connects by Bluetooth to my telephone. And so I've got full control of the APRS system on my phone. I set it up quickly, and then I can set it up to send out my call sign and some other packet information, specifically including my my position. And that goes out on a standard frequency of 144.39 in the US. It then gets picked up by other stations and repeated. And then once it's repeated, it gets also dumped onto the internet, so that people can go to aprs.fi and track position. And I was not able to show the screen tonight, but I've got a full track of my trip tonight from my house out to Para. So we've set it up and worked. Go, Daryl. Question is, where's my GPS receiver? It's in my cell phone. Right, the cell phone constructs the packets and sends them out to the TNC. Okay. So then I know how to set that up. APRLs, I can also send individual messages. For instance, if I need to talk to SAG boss or big boss on the ride, send a message to that particular identifier. If I get a message coming back to me, I get a ping on my cell phone, so I get it right away. It's been useful for some very important traffic on the bike ride. A couple of years ago, a message came down from the aid station. This high school aid station is out of pickles. Does Tennessee Pass have some pickles they can let us have? And so there was much traffic around that. The next year, the local hams all came to the ride wearing bright green pickle t-shirts. Anyway, I don't get to ride bikes long distance anymore, but this is a great way to spend a weekend in the mountains and to help out on a good cause. And the radio is just a bonus part of it. And that's why my Go box looks like that. I've got, oh, here we go. I got 2 antenna connectors here. So I put mag mounts on the roof. And the other thing that I've got is a fan just in case, but I haven't needed that.
All right, thank you.
Yes. Rick, one before you go, one more quick question. Was this just something that you did, or were other people that were working the ride, did they have similar setups, or were they inspired by anything that you put together?
This was my own solution to the problem. A clever fellow might buy a radio with all these capabilities, but I decided instead to use the radios I had and cobble them together in a tackle box.
Got it. Excellent. Thank you.
Okay, so this project started some years ago when I was yeah, this an article, but I didn't mention the other article. There was part 1 and part 2 later in paragraphs. So you go to paragraphs, just you know, use the keyword my name, call sign. You find the later articles. But Originally, I started with a Raspberry Pi 2B, and it was grabbing data from a Ramsey Electronics DDF1, and you can look that up. Ramsey DDF1, look it up online, download it. To understand what my thing does, you need to look at the circuit for that. It's a free download. Okay, well then, yeah, next. Okay, so then when the DDF1s became unavailable, I acquired a Raspberry 3 Pi donation 3B, RPI 3B from Henry, W6REK. In fact, he gave me another one too. I was supposed to make an Echolink node, but I never got around to that. I really have to. But anyway, so I started, I realized, okay, you can't buy these things anymore. And you had to pay $400 for the DDF 2020T. So let's see if the Raspberry Pi can do the whole job all in software. Well, almost, because you have to have antennas, you have to switch them. And okay. What I put together is a unit that has a Raspberry Pi 3B, although I now found out that the Raspberry Pi 02W, which is only 15 bucks, it's a 17, I think, at Central Computer in Fremont. So that one is a lot cheaper than Raspberry, than 35 bucks. And it runs my program a little slower, half the speed. But my program, thanks to Henry's W6REK G4 transpiler, that sped it up by factor 4. And so I take about a little over 30% of one core only on the Raspberry Pi. And it runs fast enough on a 02W. Okay, so the unit receives radio from a receiver in the left channel, in the right channel. It receives sync pulses. And oh yeah, you see at the bottom there, Christopher AI6KG concocted this thing when I first started the project. How much time I have left? Okay, so when I first started the project, I was doing software loops for timing, and it appeared to be working. But every now and then, Linux jumped in. I couldn't keep it. I asked Sri. Oh yeah, I got to give credit to Sri for getting me, and Christopher and several other you guys who helped me, because I'm just a beginner in Linux. So anyway, they told me, "Oh, there's no way there are certain Linux commands that you can keep. You guys know, I'm sure. There's no way to keep Linux totally out of your work. It's going to clobber you and interfere." Well, Christopher came up with this PWM configuration that if you do the top or the HTOP program, there's nothing running. It's just the PWM is configured to do the antenna switching, and every time the antenna 1 comes on, it gives a spike. So, okay, next. So right now, the program it's been running for a long time. It's very stable. And I call it now the RPI DDF, for doppler direction finding engine. That's motivated by the AG6W packet engine. But I hear that it's no longer vogue. People use Dire Wolf, I think, for packet. Anyway, I call this the DDF engine. All right. And so it's tossing out bearings to Robin's site, KN5R. Right now, if you turn on your phone and go to that website, you'll see a vector 20 times per second flying around crazily. But when you do that, if you turn on your phone, look at it, have somebody key up the repeater, and you'll see it starts to point to the repeater. Of course, that's only temporary during development. The object is to have a high elevation nodes. We want to look for these jammers, where they're coming from. And the nodes will be all vectored to the input 14463. Okay. Yeah, I don't have a 2 meter antenna radio right now, but I'll put that one back together soon. Okay, next. Okay, so now, I mean, interesting enough, Soren KN6YUH here came up with a trick that I could use to, aside from the RDF network, I figured, well, I want to use the RPi02W in my car, and I just wanted to know what's the bearing relative to me, to my car. So Soren cooked up this program that makes your Raspberry Pi Zero, and actually any Pi. Well, he'll explain, I guess. But with the RPi02W, it has Wi-Fi, Bluetooth, and all the bells and whistles. So in my phone, on my tablet, I can just set that on the dash. Soren's program will show me the bearing as I hunt. Okay, next. And that's it, I guess. Next should be Soren.
Well, hello everyone. My name is Soren, PN6YUH. Been a member of the club for about a year, but I don't have time to talk about me, and I want to show a few slides, and I think we have 6 minutes each.
7, you're good.
7, okay. I'm gonna strive for 5. So it was a Sunday, I think, and I was doing a barbecue, and I hear Andy on the repeater talking to maybe Alexei, and the discussion was about how can you get with the system that Andy had already built, which was giving some bearing information as a string, which was just sent out in the cloud for Robin's server to decode and plot on a OpenStreetMap kind of view. How can you run this locally? And you know, I started saying, there is a way where you could just run this thing as a web server on your Pi, and then you can connect through a browser, because this is kind of a well-known path that you can take. And from there, I started prototyping, and I made something that kind of worked using fake data. And eventually, I put it up on GitHub. I created a para org. Um, um, it's called an organization on GitHub, which is just me and Bob so far. But I've published a few things privately there. So if anybody, I guess I didn't talk to Bob about this, I sent him an email, but if anybody wants to put something radio related there that has something to do with para or radio projects, we can probably carve up some space in there for the rest of you. Um, so things start small, make this work. And then it's like, oh, it would be nice if the colors would be the magnitude of the signal. So it's not just some random colors. Or what about some more, nicer color palettes that people can actually see, not some random shades that I was coming up with, or even a dark mode. So, gradually, all these things, one evening at a time, they came together, and I've started releasing them and auto building. But I think we can now go to the next page. This is a summary of what the thing does. So, Andy has his system, the antennas and the radio, and the audio goes into the Raspberry Pi, and the Pi is switching the antennas as well. And the thing is that if your Pi is connected to the same network, either wired or wireless to your laptop or phone, then you can access the bearings that his program emits can be just interpreted by this application that then has a web interface, and you can just look at that web interface from your browser. And so it kind of simplified and kept everything in the Pi, and everything else you need is a browser. I guess another version would be you could just have a screen on the Pi and you could just see everything locally, but then it's so much cheaper to make an app, a web app, than making a real native app. So if we go forward one more, um, so as I was saying, the app doesn't do, it's not smart at all. It just reads the data that Andy's program is coming up with, the bearing and the magnitude and the timestamp, and then it keeps them in a memory structure with the length that is configurable from a parameter. You say I want 100 dots, it's gonna keep 100 of them, and it also expires the latest ones that were older than 2-3 seconds, whatever you want them to expire. And then it just plots them from the edge of the compass, so it's kind of clear which angle it's coming in. and they move towards the center. So, as they kind of move around, some of them are closer to the center, some of them are further on the edge. I'm generating SVGs as like a very deep technical thing. Instead of coming up with like images, I'm just generating SVGs, like which is a vectorial format. And every browser in this world can look at an SVG and show a picture. So I just change the text, which is the source of the SVG, and then the browser plots the rest. And if we go to the next page, this is just a bunch of flags. You start adding a lot of flags. I guess most of them can be the sensible default. You don't even have to touch them. But the important ones are that you can say how many bearings you want to cache, and that's starts with the 20. There are bigger dots and more spaced apart towards the center. It supports you providing your own colors. Like if you can give it five colors, and it's going to divide every 200 values of magnitude are going to pick one of those 5 colors, and that's the colors you're going to see on the screen. How long do you want them to stay before they expire? It supports another format of the padded timestamp that was actually not used by the app, but I think those were the plans. And how often should it pull data within the page? It does a JavaScript fetch from the server every so many milliseconds, so you can kind of get the idea that things are moving as opposed to refreshing the page. And then there is a table at the bottom, just under the compass, that shows you the last so many entries. So you can see some numerical values and timestamps of what time you received what. So if we go next now, because this was a lot of boring stuff, this should show something. And there's like a screen grab that I took. This is normal mode with the accessible colors, as I call them, which probably should be the default. But this is based on fake data. So I have a bash script that generates a bunch of these lines, and these lines are decoded as if they would be coming from Andy's software. And then based on the magnitude, they give it the different color shades. You see the 5 different colors. And whenever they expire, they turn into this kind of transparent grayed out. So you know that this was an old point. It was kind of there, and you can see it where it was. And I played a bit, and unfortunately I don't have access yet to kind of make with real data. But the next screen is doing the same, but with the dark mode. I wouldn't call this really dark mode. I just made some gray there and chose some random colors, but they are not as strainy for the eye as you would be driving around in the middle of the night, and you get this strong light in your face. This is more, and again, you can play with the main colors, and it's not super hard to make the background another, you can override it and so on. So hopefully at some point we can build some of these and we can run them. I had an idea that maybe if you run a web, kind of an X server on the Pi, you could potentially just render the browser on the Pi on a small screen. So you don't even need your laptop or your phone or your Wi-Fi. But let's see how this works first. And then I guess we can take it from there and make it more kind of advanced. And again, the code is on GitHub if you want to. It's not really nice. I didn't write any tests for, I wanted it to be fast. So I didn't want to spend hours and hours to write unit tests, but it's kind of simple and it's written in Golang. So if anybody wants to contribute or file feature requests, it's all there. Thank you very much.
Just
This is a little 0.7-inch display online. I bought this for a few bucks, and but I haven't written this out to drive it yet.
Andy, put it under the camera there.
Oh yeah, open it up so people can see it. And online, the ad says that they have a demo app. Oh, sorry, I bumped this thing. They have a demo app. You want to reconfigure this? This is just pointing.
Well, that's okay. Actually, we can try.
Okay, and the demo app is really funny. It's a picture of a human iris, a blue-eyed person, and the demo says, okay, you click on this and the eyeball moves up or side. So it occurred to me, hey, that would be an interesting display for direction finding. Go where the eye points.
Okay. Thank you. Thank you, Eric. Thank you, Andy and Soren. Great work together.
I realize now that I practiced this, but not while holding a microphone. So it's going to be a little interesting.
You can use our assistant Alan if you need a third hand.
Except for unzipping the bag, should be okay. So it took me a little bit of effort actually to decide what I was going to bring today, as I've had a few fun projects here. But what I settled on was my Poda soda kit. And this was built specifically to be very small and lightweight so that it wouldn't take up a lot of room in my pack. And maybe I could carry something else or go a little bit further than I could if I had something heavy. So a few different pieces. Start with the antenna system. This is just an 84-foot random wire antenna made out of magnet wire and kite string. That's all it is. Just looped together and knotted in a couple of places. Little pin connector here goes into the BNC terminal. A little bit of wire and a ground stake forms the counterpoise, and we're done. It's so small and lightweight that I actually carry two of them in case I break one. That was 41 foot was the first one that I built. I think it's 28 gauge wire. They work just fine for a few watts, which is all I'm doing anyway. And the long one will tune down to 80 meters pretty easily. Most of the time I'm going somewhere with trees. So an arborist kit is all it takes to get into a tree, just slick rope and a bag of lead weight. Thanks to the folks on Discord for introducing me to that method. I would not have figured it out. I was hitting myself in the face with lead shot out of a slingshot. Do not recommend it at all. Once in a while, I'm going someplace without trees, beaches, barren hilltops, and deserts and such. So leave the arborist kit at home and bring a simple kite. This is just a regular diamond kite. I think this cost me $20. It's a little bit larger, a little bit on the larger end. It's 36-inch wingspan, but diamond kites are really stable. So I can just throw it out there and then hook it onto my backpack or a table or something with a carabiner, and it'll just hold my antenna, even in relatively light wind, indefinitely. So that's what gave me the idea for the kite string is holding the antenna. Why carry one more thing? The antenna only adds a few grams to the load that the kite has to carry, so it doesn't change the flight performance at all. And then tune that up with the simplest, cheapest, lightest weight manual tuner that I can find. This is a little Z-Match tuner with the world's simplest SWR meter built in. The tuning procedure is turn the knobs until the light goes out. And that's it. So even I can manage that. And then, of course, the fun bit here is the actual radio. This is built around a QDX transceiver from QRP Labs. It's a little 3 to 5 watt, depending on how you build it, digital mode transceiver. It does most of the digital modes. You can buy them in kits for 80 through 20 meter, which is what this one's built around, or from 20 meter to 10 meter. But if you're willing to tinker a little bit, you can actually make this work anywhere from 2200 meter up into VHF. I don't remember exactly where it stops, but it'll faithfully spit out 5 watts pretty much anywhere you want it to. And it's a really simple radio. What I did was add on a lithium polymer battery pack on the side and a little battery management circuit that keeps me from blowing up that battery. Just takes the battery out of circuit if you give it too much voltage or you drain it too far. This is all off-the-shelf components just assembled into the rig here. On the side, under this 3D printed protection cover here, is a toggle switch that takes the battery in and out of circuit. This just keeps me from bumping it around in my pack. And then here is a USB charge controller, USB power supply coming off of the battery to charge whatever USB device that I have plugged in. And the reason for that is I'm operating FT8 off my phone. I was carrying this anyway, so this doesn't add any weight or complexity to my pack. The QDX is giving us CAT and audio over its USB port. iPhones aren't kind enough to us to allow us to actually use that CAT control, so I'm stuck on a single mode and band unless I have something else with me. But I can take the audio here, run it to the iPhone, and run power back from the radio through just a a cheap adapter. And the reason for that power is iPhones in particular, they really don't like you to draw any power over the USB ports to some accessory. Most Androids will let you. iPhones will kill the USB connection as soon as they detect that you're drawing a milliamp. And unfortunately, the radio will leak a couple of milliamps of current if the 5-volt bus on the radio is a fraction of a volt lower than the 5-volt bus on the phone. So this is actually something that worked on the bench and then ceased to work in the field because of that. So I added the USB controller there. So all of this comes with me on a POTA. In the tree configuration, it weighs just under 4 pounds. In the kite configuration, it weighs just a smidge over 3. So it's really lightweight and easy to carry. Has about 5 hours of operating time on that battery, which is severe overkill, but that's the battery that was in my junk box. So that's the battery that went in the radio. Because I'm not buying another battery just because this one's a little big. And if I'm going on a multi-day adventure or I want a little more time, this is an off-the-shelf USB-C battery charger that can power that from another USB battery bank or anything that can power a USB device. So with you know, a cheap little battery bank or you know, things that we commonly carry with us for a backup power, I can extend the power on this to multiple days of operating. And that's the whole kit. It's incredibly simple and has been very effective on POTA.
Justin, question for you. Going back to the antennas, the small little transformer part,
Transformer part.
is that what's right at the BNC?
Yeah, so there's no transformer here. This is a BNC to screw terminal. And this wire coming off has a female DuPont connector
Ooh.
on it for the pin. Originally, I screwed that in. But then if you're actually trying to launch a kite, you sort of have to hold it backwards and hold the ground stake in your hand while you're trying to unravel it and get the kite to launch. Not fun, not effective at all.
Okay, because it looked like one of the K6 ARK. I'm not sure if you're familiar with him. He makes these mini transformers that would be like about that big. So, but that's pretty cool.
Nope, only transformers in the Z match.
Got it.
A little transformer coil there.
Thank you very much.
So this is my, and you don't have to leave this slide up. You can take and just do that on full screen if you want. All right, KK6DAC, Rachel. So this is not going to be the snazziest high-tech project. This is a very manual labor. It's lots of soldering, but it's not high-tech in any way. But if you do any work in the field, you've either needed this project, needed this kit, or you will need this kit. We were out at Quartz Fest, and we were camping out there. Turns out, one of my tent mates out there, needed a particular adapter. They had a solar panel. They needed to run it to a 5521, a barrel jack. And so they came by and said, you wouldn't happen to have, you know, MC4 to barrel, would you? And it's, oh, no, I don't. But I started thinking about that problem. And so I said, you know, what you can do is certainly take some MC4s, put them, at first I thought, well, I'll just make a big connection in the middle and they'll all be connected. You just kind of pick and choose. But then I thought about, well, you can make this expandable. You don't have to just use these connectors that I decided are handy. You can infinitely expand this by just putting Anderson power poles on one end of your connection and whatever else you need on the other end. So you have MC4s, both from the solar panel and to the battery side. You can then hook those to the barrel connectors, which are here, 5521. And of course, there's spade connectors, there are battery clamps, there are cigarette lighter. If you're into RC, there's all these EC5, EC3, EC9. And of course, you got to connect something further than about 12 inches. So it's 10 feet of 10 gauge wire with power poles on both ends. And of course, if you're concerned that you might blow something up, you have all the there's inline fuses with extra fuses in case you blow something up. Inline fuses are both on the positive and negative side. Power poles for both the 50 amp as well as 75 amp. So there you have it, a collection that you'll never, hopefully, you'll never be out in the field and find out you're missing and you forgot your cable. The other thing that's cool, I decided to put as many Molex connections. So this fits really most 50-watt mobile rigs, and then for 991, FT991, as well as several ICOMs, and then for the FT857, 897, several different ICOMs. So if you happen to forget your radio cable, there you go. You got everything you need. And you could hook it to a battery just like that with a fuse. All right, that's it for me.
Thank you. Thank you.
Okay, I'm gonna just close this one. So this project is actually now related to the ham radio. I do have a project running right now, but I cannot, I couldn't finish it today. So that's the topic for the next year. And today I'm gonna talk about bass guitar. And I actually made regular bass guitar to stand-up guitar. So that's the topic. Let's see. This is the guitar I actually came across at Guitar Center some time ago, and I was used in $144, and just I just grabbed it, and I just fooled myself, and I really enjoyed it. Then just recently, I came across Paul McCartney's video, and I just show you the clip right here.
The interstate, Elvis driving, Scotty Moore and Bill Black, and this little baby strapped to the roof rack. Well, since my baby left me, I found a new place to dwell. It's down at the end of the lonely street. It's Heartbreak Hotel. It's so lonely, baby. It's so lonely. You'll be so lonely, you could die. Well, if you baby leave you, you've got a tale to tell. Just take a walk down on the street to Heartbreak Hotel. You'll be so lonely, baby. You'll be so lonely. You'll be so lonely, you could die.
Well, let's see. After I saw that, I actually really wanted to try acoustic, stand-up bass, and I looked for the cheapest one that I could find, and it's actually costed like $700 to $800, and I didn't want to touch that kind of money. So what I actually did was, since I have this fretless guitar, this bass guitar is, by the way, it's a fretless. It's like a acoustic bass guitar. I mean, a stand-up guitar that you saw, and I thought maybe actually make it, upright so that I could maybe mimic the stand-up, bass. So what I actually did is basically like this, and when I did this, I just tried to be careful so that I could actually play in both styles, the conventional styles, as well as this stand-up style. Now, if you see this brass part, that's actually garden hose cap. And this brass spots, on the stick is also the parts. So I pick it up from the Home Depot and stick in this, this uh, well, it came from the broom. I forgot where I got it. And I actually basically put it together like this. Now, is it usable? I think it is. It is a bit smaller, but all the practical purposes, actually, it seems to me, it's actually works like a startup base, And however, there's a one difference is, which is, the standard base, you can use a bowl. Unfortunately, this, my guitar is actually, the strings are so close, so you really cannot use a bowl. So that's the probably, drawback. So now, just let's see how well I can mimic Paul. How about that? Okay, so I actually copied the Paul performance and see if I could actually copy it.
Well, since my baby left me, I find a place to dwell. It's at the end of lonely street, a great hotel. I'm so lonely, baby. I'm so lonely. I'm so lonely, I could die. If your baby needs you, you got that tale to tell. Just walk down the lonely street to a great hotel. Well, you so lonely, baby. You so lonely. You so lonely, you could die.
So at the end, I think, it was just a silly project, but I got a kick out of it.
Masa,
That's all, folks.
you're getting a huge clapping and appreciation for that. So thank you very much.
Okay.
Very cool. All right, like a box of chocolate. You
One-
never know
one-
what you're gonna get.
One real quick question for him.
Sure.
Did you consider making a very tiny bow?
I actually tried the violin bow, because it's smaller, but still the string height is so close, so it is really difficult to actually hit just one string. Hello? Did I actually do something wrong? Can you
No,
hear
you're
me?
good.
Yeah.
Yeah, we got you. Can you hear us okay?
Yeah.
Okay, there was another question for you, Masa. Hang on a second.
Okay.
Well, it was more of a comment. On a stand-up bass, the bridge, the strings go across to take the vibrations into the body is curved so that the strings are not in a flat plane. They're actually arched. So you can hit the strings one at a time with the bow by varying the angle of the bow. The bridge on the guitar is flat, so you basically hit them all at once.
Yeah, exactly.
Hey, thank you. I'm gonna start my timer here. Make sure I don't go over.
He's so efficient.
Okay, hello. I am Connie W6EFI. Been a member here for a couple of years. And I'm a bit of a late entry to the homebrew night, but I always have like 5 things going on at once, so I just pulled one out. So let me give me a minute here to set up my radio. Let's see. I think I need to turn that over. Okay. Yeah. Okay. So oh wow, this is weird. No, you don't need to move that. It's funny. There's a little lag between what I'm doing and what's happening on the screen. So guess what I have as a base station at home. So I'm gonna mock up my base station here. Let's see. You got a radio. You got to have you know, you got to have the computer, and let's see if we can hook that computer up. Pull that. Well, of course, I've got, you know, I got a paddle, and let's see what else have I got here. Let's gotta hook this stuff up. All right. Well, you know, the laptop's connected to the radio. I've got a paddle. I spend most of my operating time now in CW. So I've got the paddle. I didn't bring my good paddle. But I also have, you know, a straight key. And I operate both the paddle and the straight key. And let's plug them into the radio here. Let's see, one's here and one's here. So we got them both plugged into the radio at the same time. And I'm sort of getting interested in some of the contests that are going on and POTA and so forth. And with this particular radio, you've got a lot of digging through menus to change some of the you do have the ability, you do have a contest keyer in the radio, but you have to push a button and turn a knob and go to a menu, and then you get access to the touch screen. So that gets annoying real fast. And you know, this is basically a top scrolling shooter, these contests. So I built this, which plugs into the radio. You push a button and, you know, it calls CQ, and then 599 CA, and then, you know, I've got again, you know, so I could press that button a lot. So you just push a button and it'll send a contest exchange. Now, to be fair, they do have an external contest controller. It's an ugly little black thing that's uglier than most computer mice. But I like this because, you know, this basically is a point and shoot game. At least that version of CW. But you can see I love the old school, the straight key stuff. And another problem that I was having with this radio, not having enough knobs and buttons on the front, is that I like to switch between these two in the middle of a QSO. Yeah, because I'll be just chatting away with somebody on the paddle, and then he'll be telling me about how he was in the Signal Corps in the Navy in the 1940s, and he's got this amazing key and this collection of keys, and he's on a radio that's got tubes that are half ceiling height and stuff. And I'll go, oh, okay, I'll switch to my key. And then the problem is to switch from this to this, even though they're on a Y connection, you have to do a couple of things. One of which is you have to tell the radio that I don't want the keyer to run. When I hit this, I don't want it to go da 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 da. I want it, when I push the button, I want it to go da. So you have to dig through some menus to switch that. That was annoying me a lot. And so, you know, I wanted something where I could just push a button and toggle between them. You can't there isn't a button on the front of the radio that'll do that. See, this doesn't have any buttons on it. It's annoying. So also when I am operating CW, one of the important pieces of etiquette is that you match your speed to the other person. So you're not always contesting this thing, you know, you point and shoot. That's one style of operating. But if you're actually using, you know, you're using a paddle or a key, and you're just out there, you know, calling CQ or responding to somebody, or your slow speed contest or SKCC, straight key century club, or just, you know, random, you want to calibrate your speed. You want to match your speed to the other guy, especially if they're slower. So I like to do that. I like to make sure that I'm matching speed. And even if I'm using the straight key, but particularly with the pedal, the way I like to do that is to turn off the send mode. In other words, turn off break-in mode on this radio. It's called break-in mode. On other radios, you'll see practice mode or transmit mode. There's a way to turn off the transmitting of the radio when you're keying, but still hear the side tones, so you can hear what you're doing. That's really handy for matching speed if you have a radio that's got a keyer in it, like all modern radios that you can get today. Even the little QRP radios have keyers. And I'm done. So just to finish, what I like to do is I turn off that transmit mode, and then I'll turn the speed dial on my radio and listen to myself and make sure that I'm matching their speed, then turn send mode back on. Well, turning send mode on and off, or break-in mode on and off, is an even more pain in the you-know-what than turning on and off the keyer. So I built another thing that just using a cheap number pad. I built a boy, that's hard to coordinate. I built a little thing that plugs into the computer that's sitting next to the radio anyway, that turns on and off. Is it here? Oh, okay. Yeah, that turns on and off. So that's upside down for you guys. Oh, okay. Oh, I see. Okay. Yeah, so it turns on and off the keyer, and it turns on and off break-in mode, plugs into the computer. I have a Python program running on the computer that traps the key presses and sends a cat command, a command to the radio through USB that tells it to turn those things on and off. So anyway, let's call this point and shoot CW control. And one more note about this guy is that there's a ton of space in there to fit a Raspberry Pi Zero. So the next step is going to be put in a little Pi Zero in there, so it's a standalone control. Thank you very much.
Thank you.
W6CFI.
Thank you. You know, your last button thing there, keypad, is very similar to this Stream Deck. Have you heard of a Stream Deck? Oh, switch over to that camera real quick. This is a Stream Deck that I put on my computer. I haven't been using it, but it allows me to switch to any program on my that I put in the URL or jump to or whatever and it works like a charm.
Okay, while we're working on getting the view here, it's a small display, as you can see. So, yep, small display. So hopefully you'll be able to read it if you can get the camera closer. My name is Mark, Alpha Delta 1 Mike. This is a Raspberry Pi Zero 2W with a header and a little 135 by 240 color display. And so what we have on there, I think you can see it now, is a date and some times. But you'll see right away, the ham part of this is I have here a microphone, a small Kenwood microphone, most importantly with a push to talk switch. So I'm going to press the push to talk switch. And what you can sort of see there, I'll have to tell you, I guess, because maybe it's hard to see in red, is a timer that is counting down from 90 seconds. Okay, there you can see it's at 75 seconds. It's continuing to count down. I'm gonna actually, since I'm impatient here, I'm going to change the timeout to 15 seconds. Oh, I went all the way. So there, so one more. Is now counting down from 15 seconds. So I can change it from 90 to 60 to 30 to 15 if I want with a button. And so when every time I press the push to talk switch, it starts over from the top. And once it gets down to 5 seconds, it starts blinking at you. Hopefully maybe to get your attention. And then if you go past it, it goes negative. That's it. That's the whole thing. Okay. That was like maybe a minute or two.
Do you have plans available that if someone wants to learn how to build one?
Absolutely. So anyway, yeah, the Pi is like retails $18. The display retails 15. You can probably find them for less. The display is cheaper on AliExpress. And it's just 2 wires to hook up to the push to talk. So the push to talk, there's all you need to do really is have a ground wire and a wire to the push to talk, either on the microphone or on the data port of the radio. Either way, there's a pull-up resistor in the radio so when you close the switch, it brings the signal, pulls the signal down, and that's all there is to it. And yeah, I can certainly provide. It's just a short Python program. By the way, this is really easy to do. One of the nice things about Homebrew Night is that it motivates you to actually do something. So there was a deadline. I thought about this a few weeks ago, but I finally started on it this afternoon. And I went to Anchor Electronics to get 2 jacks so I could hook up the mic, and then got it working. And then it was working by 6 o'clock. And then Soren helped me get on the list since he had already closed the list. So thanks, Soren. Yeah, it took more, it took a good part of the afternoon to get this working. Much of the time actually was trying to find all of the Python modules and getting them installed to operate the display. You go into this dependency hell of figuring out what you need. But once I got the put like 1 pixel on the display, then it was pretty easy. Yeah, sure. Yeah, we could do that. Actually, nothing I could do, if I wanted, is I could interrupt the push to talk signal, and have the push to talk go into the Pi, and then the Pi deliver another push to talk signal, and then I could actually just cut off the push to talk at 90 seconds and bring it back. Maybe only like half a second to reset the repeater, and it would do that automatically for you. Maybe interrupt a word a little bit, but otherwise it would automatically switch it off.
Or perhaps put a small speaker and get a tone?
Yep, you can get it. Yeah, I don't have any speaker or anything on this, but yeah, I could try and put on another connection to one of the GPIO pins to put out some audio. Even more advanced, we could put in some audio processing, have the audio delayed by half a second, so that it would put that interruption in only between pauses in your words, and it would give you a half a second delay so the repeater can catch up with you when you start.
Okay, everybody, I'm sitting at my desk minding my own business, and all of a sudden I lose power in the house. I don't know why, but I'm panicking because now I can't watch YouTube, or I don't know, something's dead and I need power. I'm looking around, and gosh, all I have is this like DeWalt battery. It's like 20 volts, and but I need 12. How do I do this? I made an adapter. So these adapters are available online for all different types of manufacturer. This one happens to be DeWalt. And what I did is I took this box and I, one moment, please. Just ordered online one of these DC to DC converters. Put it inside. Took my battery. Ooh, snap. And if you want to change this screen, Ben, I don't know if you can see. Oh, let me take that off. It's probably flashing. There you go. So I installed a USB A and C, and of course we have to have our Anderson poles here. So now I can take my phone to my cell phone, and then of course I've got cell power now, and I can also now use the Anderson power pole. This takes me to project number 2. Online, you may have seen a lot of YouTubers or things talk about these cool little Anderson power pole to Wago connections. I think, or Wago connections. They're like electrical double-ended clips where you can just put wire in and shut it for electrical continuity. And they're selling these online. They're calling them quick poles for like 20 bucks, but I made my own. You take some really stiff brass wire and you measure it out so you get it all lined up. Then you use the shrink tube. And what this does is it makes it very easy if you're in a situation where you want to have quick power pole connection, and then you could put whatever on the other end, kind of like what Rachel was doing, but this is like, doesn't have an end to it. You could put whatever you want. In this case, it's little jumper wires. So I think did I put a fuse inside? Maybe not yet, but yes. So I'm running this little fan now. So just a little DIY power on the go for your utility battery so you could use all the resources available. That's all.